Hello. Hello.
Hello, Mr. Rahman. Good evening.
Yeah, how are you?
Alhamdulillah, good. How is the condition now, Mr. Rahman there?
Yeah, now Alhamdulillah, everything is good. So already created the interim government.
Okay.
Okay, so now everything is good for network or other facilities. Everything is good now. Yeah. Okay, so
Very good.
Okay. Okay, so let me share my screen.
Yeah.
Okay, now can you see my screen?
Yes.
Okay, so basically you enroll this online training program on Google Earth Engine for Python API for machine learning and deep learning. So basically in this online training program, we are just integration Google Earth Engine with Python for machine learning and deep learning. So in this online training program, first of all, I will try to explain about that total syllabus. Then you can easily get the idea how you will teach from me. So all of those things I will try to explain one by one. So basically here you can see about the course content for the first day. So basically today's session, I will try to discuss about that in inter overview of Google Earth Engine capabilities and application in Python API. Okay, and then I will try to show you that how we can easily set up the Google Earth Engine, and then understanding the Google Earth Engine interface and dataset, and setting up the Python environment for Google Earth Engine. Then we try to discuss about the installing necessary library such as GE map or other types of necessary library, how we can easily import. We also try to discuss about that, and how we can easily authenticate and initialing the Google Earth Engine, and basic operation of Google Earth Engine and Python API, mainly loading the data set, then basic image operation. We also try to discuss about that. And second is mainly try to discuss about that introduction to remote sensing and satellite data, and common satellite data such as Landsat, Sentinel, MODIS, how we can easily filter and work with the Python API, and accessing and visualizing the satellite image in Google Earth Engine, how to filtering the image collection and image maxing or clipping or reducing, and exporting the image data from Google Earth Engine. We'll try to discuss about that. And mainly third day, we try to discuss about that introduction to machine learning, and then how we can really apply the different types of machine learning such as supervised, unsupervised, then overview of machine learning and definition and application, then different types of machine learning algorithm, introduction to the popular machine learning libraries such as scikit-learn or TensorFlow or Crass. So these type of things how we can really apply in Python, and then extracting the feature from satellite images, then preparing the dataset for machine learning training, and the splitting the data into training and testing dataset. We'll also discuss about that. Mainly fourth day, we try to discuss about that supervised learning model. Different types of supervised learning model is available, such as linear regression, then decision tree, random forest. Okay, then how easily training and testing model with satellite data, then evaluating model performance, land cover classification using random forest, and vegetation index prediction using linear regression. We'll try to discuss that in the fourth number class. And fifth number, we try to discuss about the deep learning. We start the deep learning from that fifth class. In the deep learning, we try to discuss about that neural network, mainly CNN, convolution neural network, or artificial neural network, difference between that machine learning, deep learning. Then we introduction to TensorFlow and Crass for deep learning, preparing the satellite data for deep learning model, implementing the convolution neural network and image classification, how we can easily apply the CNN, this model, and make the image classification. We'll also discuss about that, and training and evaluating the CNN models with satellite imagery. And 6 number class, we try to discuss about that transfer learning and pre-trained model, implementing the unit for segmenting semantic segmentation. We'll also discuss about that, how we can really apply the unit, and then for semantic segmentation. We'll also discuss about that, and applying the transfer learning for land cover classification, and using the unit model, how we can easily make for the high resolution mapping. And 7th number class, we discuss about discussing the real world application such as deforestation monitoring or urban planning or disaster management or case studies showcasing the integration of Google Earth Engine and machine learning and deep learning. Then we talk about that different types of practical project. Okay, and then we complete our total 7 days online training program. So basically in this online training program, we integration with Google Earth Engine with Python for machine learning and deep learning. Okay, so this is the full syllabus. I will try to explain all of those things one by one. I hope you can easily learn all of those things for this total 7 days online training program. You can easily learn. Okay, so first of all, here you can see we already know about that. This is our code editor of Earth Engine. Simply you can go to this link. We can easily access our code editor. So basically this code editor called as a JavaScript API code editor. Okay, so we already know about this code editor, and this code editor we can write only for the JavaScript API, only write for the JavaScript programming language.
This is Java. Okay,
yeah, it's only available for the Java. But JavaScript programming have a problem. This programming language have not much library. Okay, but in the Python we find out lot of powerful library. So if you search on the Google, suppose I simply search the Python libraries for, suppose for data science, I simply search data science, then you can get all of Python library. So here you can see the list about that: NumPy, Matplotlib, SciPy, Scikit-learn, Seaborn, Keras. So there's a lot of powerful library we can easily find using the Python. Okay, but in the JavaScript it's not available, and it also hard because they're not much the popular library. We can easily get all of Python library in the Python. Okay, but JavaScript is not. So that's why it's very important to use the Google Earth Engine with Python API for machine learning and deep learning, because we can easily find out lot of Python libraries in the Python programming language. So that's why we can easily integrate the Google Earth Engine with NumPy, Matplotlib, Scikit-learn, Keras, or other different types of popular data science Python library, and we can easily work for that. Okay, so this is the benefit to use the Python. Okay, so that's why we are in this online training program, all of those things we are just use the Python programming language, not Java. Okay, JavaScript is also okay, it also do a lot of things, we can easily do it, but Python is more powerful because there are a lot of libraries is available. We can easily integrate this type of library with Google Earth Engine and work with that. Okay, so now how we can start? So this code editor is for JavaScript API code editor, but now I want to make a code editor for Python API code editor. For the Python, we can easily use the code editor, mainly Google Colab or Jupyter Notebook is also okay, but Google Colab is more interesting. So just I simply search on the Google Colab. Just simply search on the Google. Then just click on here. So here you can get this type of things about the Google Colab. Okay, so just click on the new notebook. So now it open a new notebook. So basically all of those things, all of code, we are just write in this code editor. Okay, in this code editor we can write all of code. For our necessary code we can write in here, and this code is only right for that Python programming language. We can easily do it. So you can see IPYNB. So this is the extension about the Python. So we can easily Python notebook. So this in the Python notebook we can easily write for the Python programming language. So just I simply take here first class and then I just rename it. So this is my code editor. In this code editor I can write all of my code. So now this is the Google Earth Engine, and this is the only for the Python code editor. So we already know about that Google Earth Engine is a totally cloud-based platform. Okay, so this is the cloud-based platform, And in this cloud-based platform have a own server. Google Earth Engine have a own server. So first of all, I need to connect the server in here. So in this time there is nothing, just a blank code editor. So in this code editor, I want to install the Google Earth Engine. So that's why I can easily call all of Google Earth Engine function, all of Google Earth Engine dataset, I can easily call. So that's why I need to connect the Google Earth Engine in my code editor. So how I can connect? So let's begin this time I talk about that, how we can easily install the Google Earth Engine in the Python notebook. So let's go. First of all, you try to install a package. It's called the GEmap package. For installing this package, just write the exclamatory sign and put here the pip install GEmap. So GEmap is one kind of Python libraries. So this library we can easily handling about that Google Earth Engine mapping. So this is the package. This package I want to install. So that's why I simply call
GMap.
Yeah, GEmap. Yeah, GEmap. So just simply click on the run. Yeah, run. Then this GEmap package is installed in my code editor. So now it's working. So here you can see now it's successfully done for installing. So we can get this type of, you can see it done for the installing. And further, I take the new cell. So after installing, when you import any libraries, suppose I just install this GEmap package, this package I install. Now this package I want to import in my code editor. So how I can import? So it's very easy. Just use here the import function. So import and then put here GEmap. So that's why here you can see I simply call the import and then put my library name and then click to the run. Okay. So here you can see now it's successfully imported. We can get that right sign in here. So it means that my GEmap is successfully installed in my code editor. As well as I also need the another package. This package is already installed in Colab. So just I simply call the package. This package name is that import Earth Engine. Okay, so E means Earth Engine. So this is the Earth Engine package. And this package, this Python package is already installed in the Colab. So that's why in this time I don't use the pip install. Okay, because this package is already installed in the Google Colab. So just I simply import and run it. So here you can see it also successfully done. Okay, so further I need to connecting. Okay, I need to connecting the Earth Engine with my server. So for that I just use here Earth Engine authenticate. Okay, just I write here Earth Engine authenticate and then run it. Yeah, so run it. So here you can see now it connecting. You can see about that. Allow this notebook to access your Google credentials. So just I simply click on the allow. And further, I just connecting with my Gmail account. With Gmail, I use to make the Google Earth Engine account. Okay, so when I register in my Google Earth Engine account, I just use this email. So just I use the same email. Just click on here and then continue. And further, simply go to the below. Here you can see the continue again. So now it connecting. You can see it connecting. And before that, I also give you the another message. So your Google Colab, in this time, this Google Colab is stored in a Google Drive. Okay? Your Google Drive Gmail ID and Google Earth Engine Gmail ID all time will be same. Otherwise, it not work. Okay, so you can see here, I just use my email, or this is my email I use for creating the Google Earth Engine account. This same email I also use for this collab. Okay, collab, I also use the same email. So that's why I just simply authenticate it easily. And further, I just put the another code ee.initialize. Initialize. In this initialize, I need to define my project name. Okay, so I put the project name. So here you can see in the Google Earth Engine, I already make a project. So this is my project name. It's my cloud project. Here you click on the asset tab. Here you can see about the cloud asset. So this is my cloud asset. So ee.mijan GIS RS. So this is my cloud project. Okay. So now this cloud project, I want to connect with my Python notebook. So this is my cloud project. If you don't have the cloud project, simply you can create it very easy. Just simply you can see register a new cloud project. Simply click on here, and further you can easily put all of information and you can easily make the cloud project. So here I already make the cloud project ee.mijan GIS RS. So this is my cloud project. So this cloud project I need to mention in here. So just I put here the project, then equal, and put my project name. So this is my mijan GIS RS. So this name I write in here, mijan GIS RS. So this is my project name. I simply put in here and then run the code again. So now you can see it will work. Okay, there is no problem. So mainly when you start the when you set up the Google Earth Engine with Python API, just follow this step. Okay, just you simply import the GE map, then import the Earth Engine, then authenticate, and then initialize with your project name. So this is the step for make the Google Earth Engine with Python API. Okay, so now this code editor is ready to use for Google Earth Engine. We can easily use all of Google Earth Engine function. Here you can see there are a lot of function in the docs tab. So all of function we can easily use in our code editor. In this code editor we can easily use because I already set up this Google Earth Engine in my Python API. Okay, so now I will show you that how we can easily make the map. Okay, suppose here you can see in the in this code editor we can get this type of map. Okay, so this type of map we can also visualize in our Python API. So it's very easy. Just I take the new cell and I put the variable name, suppose map. In this variable I call my package name. So this is my package name, GE map. I call this package name and then just use at the map function. Okay, and further click the run. It will be okay. So further when I just take the new cell and print this map, click the run. So now it visualizes a interactive map. So here you can see it visualizes a interactive map. So we can easily get this type of OpenStreet map. So then further we can easily add the different types of analysis, such as different types of data or different types of layer we can easily add in here. Okay. So this is the process for setting the Google Earth Engine with Python API. Do you have any question?
Yeah, 1 second. Just wanted to, after we authenticate, we initialize the project, right? Initialize project.
Yeah.
Nice. Project which is GE.
Yeah, so this is the project name. So it also different from your side. Okay, so it's the project name. It will be different from your side because you can see you can easily find out the project name in your Google Earth Engine code editor. You can get this is my project name. So this project name we can easily use in here.
Dot and then no. Okay, Mr.
Yes.
Mr. Rahman, you have any material with you, like to how we initialize this Python code editor.
Which one?
Uh-huh. I mean, normally the steps, yani.
Yeah. So normally we need this type of a step when you write the code in the Python in Google Earth Engine. Okay. Normally set up, import the GE map, then import EE, authenticate, initialize, and then we can easily get the code editor. So now this code editor is ready to use the Google Earth Engine Python API. Okay.
Yeah.
So all the time we follow the same process. When you write your code, all time we follow the same process to importing GE map, import Earth Engine package, then authenticate, then initialize, and then you can easily set up the code. This code editor is set up for work with the Google Earth Engine. Okay. Okay.
Mr. Rahman,
Yes.
yeah, I have one small doubt. Like for potential evaporation
Yes, please.
in Google Earth Engine, do we have this vapor details?
Mainly
WAPOR.
is it evapotranspiration or vapor?
Yeah, potential evaporation.
Okay, so let me check.
Water productivity open access spot. Can we connect with the Google Earth Engine?
Yeah, it also easily. Okay, so now I discuss this one by one. Just a minute. Suppose now I talk about that how we can easily call the Google Earth Engine dataset, because here you can see when I click on the browse data catalog, we can find out the lot of dataset in Earth Engine public data catalog. So now this type of data, how we can easily load in the Python. In this we talk about that. Using this process, you can easily load any kinds of data and create the map or other time series, so you can easily do it, no problem. So here you can see in the Earth Engine public data catalog, here we find out that lot of is already available. So all of data set we can easily load in the Python, and further we also integrate the different types of library and do different types of analysis. Okay, so now I will show you that how we can easily import the data, and further how we can easily make the map, and then also other types of things how we can easily handle using the Python. Okay, so let's go. Suppose I simply click on the modis. Suppose I want to use for the modis data, and further we discuss about the later for Lancer or Sentinel imagery when I talk about the deep learning or machine learning for image classification. So here you can see that a lot of data set is available. So from here I want to choose any specific data. Suppose I want to work for the evapotranspiration data set. Just I simply search, and it's also more better. We can easily find out that evapotranspiration. Simply search. Okay, so here you can see about that. TerraNet evapotranspiration 8D global 500 meter resolution. Suppose I want to use the data. Okay, so this is the data set. Okay, so this is the TerraNet evapotranspiration 8D global. So you can see about that it's a ET, means the total evapotranspiration. Okay, so this data set I want to use in the Python, and then further I want to make the map or other things. So first of all, this data set I want to import in the Python. So how I can import this data set for evapotranspiration data set, how I can import? So just simply copy this Earth Engine snippet. So this is the unique ID. Simply copy and then paste on your in here. Just simply paste. Then I just give a variable name. Suppose I put the variable name is that data set. Okay, so now this is my net evapotranspiration data set. I simply import, and then I give a variable name. Okay, so in this time var is not need. just I simply take a variable name dataset and then put this image collection. Okay, so in this image collection, you can see this image collection have different types of band. One band name is the ET, another is the LE or PET. So different types of band we can easily find out in here. So I want to work for suppose ET. Mainly it's a total evapotranspiration I want to use, and then further I want to make the map and also analysis. Just simply copy the ET, and then I use a function, suppose select function, select this band name. Okay, so this is my band name. From this image collection, I select this specific band. Okay, and further, suppose here you can see this data set is available from year of 2021 to 2024. So this time period, this data set is available. This data set is available between this time period. Suppose I want to make this map for only for the specific time period. Suppose only for a specific year or a specific season. It can be any time period. I will simply choose in from here. So for doing these things, I simply use a function. This function called the filter date function. Okay, and I put the time period. Suppose year of 2023. Suppose 1st January from year of 2023 December 31. Okay, so this is my time period. So I run the code. So now here it will be loaded, and now I want to check how many images are available between this time period. I want to check it, how many images are available between this time period. So for that, I just simply use a function, print function, print this data set, and then I use a function, size function, I simply put in here. So now it computing how many images are available. So here you can see we can get this type of result. So it shows about that image collection loaded. So year of 1st January December, we can get this type of imagery in here. So here you can see e dot number, collection size, we can get it. So all of details we can easily get it from here, and we choose here the evapotranspiration band in here. So this is our image collection. Okay, so this image collection I want to visualize. Suppose I want to visualize this image collection. For doing these things, I just use a layer. So map dot add layer and call this dataset. Simply copy and paste here. Okay, click to the run. Okay, now we can see how we can get this map in here. Okay, in the evapotranspiration map is loaded in here. Okay, we can get this map in here. You can see at the grayscale color. Okay, and so we can get the as a grayscale color. We can easily get this map. So I want to visualize this map in the lower side, in the below of the map dot add layer. So for that, you can simply use a map. Simply use here the map and click the run. So now it show on the lower. You can see we can get the lower map. We can get this type of map. So now we are just try to add the color. Okay, suppose I want to add the colorful map. So adding the colorful map.
If we want to subset our area, we need to again load the shapefile or something.
Yes. So I will discuss later about that. So first of all, I try to make the full world evapotranspiration map. Then I just click with our shapefile boundary. So now here you can see I just try to add here the specific color. So here you can see already have some color. I simply copy this color code. Okay, just simply copy the color code, and then suppose I just paste here. Just take the new cell and paste here. Okay, so now in this time var is not need, because var is need only for the JavaScript. Okay, so now here you can see, and all of things we are just put here this quotation. It also need for that quotation, also quotation. Okay, so now this is our variable name. I simply copy the variable name and paste after the object name. Okay, so now click the run again. Okay, just okay. We'll run this code again. Then we are just run the code. Now it will be white. So now it will be set with this color. Yeah, so you can get this type of color. Okay, so now here you can see the idea where we can find out that high evapotranspiration value in the world. So basically here you can see this type of region is the high evapotranspiration. Also, this is the green color identify about that high. And you can see some region there is no data. Suppose you can see this is the desert, so there is no activities for that evapotranspiration. So that's why it shows about the blank. You can see it's a blank. So also you can see it's a blank. There is no data. So it means that there is no data between this time. Also you can see about that. Okay, so there is no data about that because there is no trees. Okay, so evapotranspiration is only occurred for the trees. So that's why you can get this type of visualization of map. So here you can get this type of map. So it's a layer. Also you can see about that. This is the layer. So different types of layer. Here you can see we can get this type of layer for that open state layer or so different types of layer. You can also put the layer name also, that it is also more better for visualization. Suppose here you can see when I just put the layer name. So just I put a layer name. I put the layer name suppose as a ET or evapotranspiration. You can put any name. Suppose evapotranspiration. So run it. So now it also loaded and we can get the layer name as the evapotranspiration. So here you can see it loaded the layer name evapotranspiration. You can get it. Okay, so you can see you can get the evapotranspiration layer name. So this is our evapotranspiration layer. We can get it. So here you can see you can get this type of things. So this is our evapotranspiration map. We can easily create, but I want to work for the specific boundary. Okay, so now how I can work with that? So for that you can easily import your shapefile from Earth Engine code editor. Here you can see we already have asset. Okay, in the cloud asset, here you can see this is my cloud asset I define in the code editor. Okay, in the code editor I already defined the cloud asset. So now this cloud asset I can easily call. Okay, suppose here you can see in this cloud asset this type of shapefile. So I want to work for this shapefile. Just click on here. So this shapefile I can simply work with that. So here you can see this shapefile I simply import in my code editor, and further I simply click on here. So now I can get this type of code. I simply copy this code. Okay, just simply copy. And then I just take a variable name, take the new cell and paste this code. Okay, suppose I put this variable name as a, you can put any name as a variable. I put the variable name, suppose ROI. So now this ROI is my shapefile variable name, and this is the shapefile. Okay, it is stored in here. So further, what can I do? I just simply use a clip function. Okay, and before the clip function, I want to calculate the average. Suppose between this time, I want to calculate the average evapotranspiration for Bangladesh boundary. So for that, I just simply use a code in here, use a mean function. So basically, it calculates the average pixel of evapotranspiration, and further, it clip with my study area. My shapefile variable name is ROI. So now click the run. So now it show the result. Okay, I think some problem. What's the problem? Okay, ROI is not defined. So because you can see, I just paste. I don't run the code. So just click the run the code again after pasting, and then I just click on here again. So now it also loaded for my only for my boundary. Okay, so now I just reload this map again. So now we can get this shapefile only for our study area. Okay, so we can get the map in here. Just simply zoom this map. It will be loaded sometime. So here you can see just simply open the one state map and also my map. So here you can see it loaded this type of hippopotamus expression map in Bangladesh. Okay, in year of 2023. You can see here some part is not no data. Suppose here you can see about that there is no data. Also you can see there is no data. So it means that there is no hippopotamus expression activities due to the less vegetation. Also you can see in the Dhaka. Okay. Also there is no data because they are the totally build up or settlement area. Okay. Also you can see the river or water body river. Okay, so you can get this type of epoch transformation map in here. Okay, so any question, please?
Yeah, clear. It's fine, Mr. Mark.
Okay. Okay, so I will send you this type all of code so you can easily practice later. And further face any problem, it's a guide you.
Sure. Mr. Rahman, I have a few questions.
Yeah, please.
Yeah, no, not in this. Like for example, for soil texture and soil pH, can we do it in our Google Earth Engine?
So basically, soil texture, some data is available in Google Earth Engine. Suppose I simply search here
Soil pH?
soil texture in the different depth. We can also get success here. You can see about that 0 centimeter depth. Okay, so suppose I need the soil texture in the 0 centimeter depth. So then I use at the B0. Then 10 centimeter depth, we can easily get it from the B10. 30 centimeter depth, we can easily use for the B30. 60. Also, you can see about the, what is the B0. We can see different types of description about that for the soil texture. You can see about that CL, CICL. So different types of soil texture list we can also get in here. Okay. So now I will show you that how we can easily make the soil texture map in Python. So it's the same way. So first of all, what can I do? I simply copy this and then paste here this and then give a variable name. You can put any name as a variable. Suppose I put the variable name is that soil data then equal. Okay, so now you can see here it's an image. Okay, so it's not an image collection. So when you can get this type of image, we can easily visualize without filtering. Suppose I just simply put at the map.add layer and then use at the soil data, this variable I simply call it will run. So now it will be loaded for the whole world. Okay, we can get this type of map without color. So this data load for the whole world soil texture without color. So now we can easily add the color. So we can easily, they're already defined some color here, you can see. So just I simply copy this color code and further I just use it in here, paste in here, and then simply copy the variable name and this soil texture for 0 centimeter depth. Okay, B0 means that 0 centimeter depth. So just I paste here, click run. So now we can easily get the full world soil texture map. So here you can see we can get this type of map for the soil texture. Suppose here you can see red color identify about one kind of texture. Also you can see yellow color, green color. Also you can see they also provide the name. You can see about name. Suppose here you can see about that. You can see the name. Suppose here you can see this color is identify this type of soil texture. Also you can see yellow is that. Also have some color with the description. Okay, so you can
So,
easily
what does that mean? CLO.
so is the soil texture type. Suppose I simply search here. So it's a short form they put in here. Soil texture name USDA data set. So just click on here. This data set is also available from the Kagli. So here you can see CL means clay. Okay, and also you can see CICL means silty clay. SSCL means sandy clay. So here you can see different types of unique values with their name. Here you can see about that CLLO clay loam. Okay, you can see LO
Okay.
is the loam. CILO is the slit loam. SALO, so sandy loam. So different types of, this is the short form and this is the description about that. Okay, you can see about that SA, mainly sand. Okay, so you can see this is the same short form. You can also get it from here. You can see about that SA, it's for the sand. So we can get this type of color, identify about the sand. Okay, CL means clay. Okay,
Yes.
then we can get that. So all of them we can easily find out in here, their full name. Okay, then you can easily identify about it. What is that for name about that? So this is the name about that. So we can easily get this is a soil texture. And now I want to work for this specific boundary. So it's very easy. Just we simply import our shapefile. Suppose I simply import your shapefile.
Can you import my file?
So just I simply import Fuji Emirates.
FUG.
Yeah.
Yeah, that one.
And I give a variable name. Suppose I put the name is that ROI. Okay. So further we are just simply clip with that area. So just I take a variable name. Suppose I put the variable name is that, suppose soil map, and then I call the soil data, paste here, and these things just clip with our study area, which is ROI. Okay, then I want to just visualize it. So just simply copy the soil map and then click, then paste here. So now we can easily find out that soil texture map for your study area. And I want to focus, just simply use here map dot center object is that ROI and click run. So now you can easily find out that your study area. So you can get this type of map. Okay, so here you can see. So here we find out this type of texture of your soil. So here identify this type of color. Here you can see about that from here. I think SALO, sandy loam. Okay, so this type of color here you can see, it's a sandy loam. Okay, and also you can see about the green color SACILO, sandy clay loam. I think SAC
Sandy clay loam.
clay loam. Okay, sandy clay loam. You can easily get this name from here. Okay, and YOLO is that, I think it's a sandy. What is that? And check it. The data set red color SA. Okay?
SA. Yeah.
Immediate depth. Okay, so if you print that, suppose I just print this file map. So now it show about this email, and here you can see the B0. All of band is available. Properties. can see about the all of name. Okay. For the B0 class name, you can get. They're color plated, and this is the class value, mainly 1, 2, 3, 4. This is the class. So basically, this data set is the remote data set. We can easily use it for getting this soil texture map. Okay, and this resolution is
for pH we have it.
yeah. Okay, so for pH, soil pH, we can get some specific region. Suppose pH, you can see ISDO soil pH. So this data set is only available for the Africa. Okay, so this data set is only available for the Africa, not for the whole world. Okay, so here you can see this data set. Yeah, so generally over Central Africa, we can easily monitor for the Africa soil pH using this data set. But for other region is not possible to use it. But for the soil pH, if you want, you can also apply the other method for calculating the soil pH. Okay, so it's also, suppose you can simply search on the Google. Okay, so let me show some algorithm. Soil pH using remote sensing. So okay, so detecting soil pH from open source remote sensing data. Just we try to get it. It's not publicly available. Suppose predicting habitat soil pH. Okay.
Anyway, Mr. Rahman, that is there, and chirps data also we can easily plot it, no?
Yeah. So any data set, same process.
Rainfall data.
Yeah. Easily. So it also possible. So for that we have to need some soil pH ground truth data. Okay. Suppose if you have some ground truth data of the soil pH for a specific region or a specific coordinate, then we can easily apply the linear regression model and we can easily make the soil pH. Okay. Soil pH is also available. Further, we need the ground truth data, mainly field data. Okay. Then we can easily make the soil pH map also.
Okay. And also temperature also we can plot it, no?
Temperature, mainly with soil temperature.
No, not soil temperature, normal temperature.
Yeah, normal pH also okay. It's also possible, no problem. Same process. Okay. Modis LST data set can also use it. It also okay, no problem. So here you can see some multiple regression model. Okay. So basically this type of multiple regression model, this type of equation we can also use. But for this type of, suppose A value, B1 value, B2 value, B3 value, B4 value, to make calculate this type of value, we need the ground truth data. Okay, so further, when you have ground truth data, we can easily apply this type of equation, and then we can easily make the soil pH map. Okay, but further we need to the ground truth data. Then to create it, this type of A, B1, B2, B3, B4 value, then we can easily apply, and then we can easily make the soil pH map also. Okay, so it is also possible to that, but for that need that ground truth data, otherwise not possible.
Okay. Mr. Rahman, can you share me that link?
Okay, after class. Okay, so well, I will make a Google Classroom for you. I will upload all of link or recorded class, everything. You can easily get it from the Google Classroom. Okay, so I will invite after completing the class. I will invite you. No problem.
Okay. Tomorrow is you available? Tomorrow?
No, because Friday and Saturday I have very tight schedule for the class. Without Friday, Saturday, other days is normal. There is no problem. Okay, so we can meet on for that Sunday or Monday. No problem.
Sunday evening.
Okay.
I just wanted, just for another purpose, small doubts. Can we meet on Sunday?
Okay, no problem. No problem.
Okay. Thank you.
Okay, so now we talk about that. So this is the process. So in this time, here against the Python. In the Python, we can easily upload it using the same process. Any data set, you can easily visualize and make the map. Okay, so now I talk about another thing. Suppose how we can easily make the satellite imagery. Okay, suppose how I can show the satellite imagery, and further using this satellite imagery, how we can easily work for the different types of operation, how we can easily apply the different types of calculation. Okay, so let's go. So okay, so suppose I want to work for the image, just I click on Landscape. Or any Sentinel is the same process. Okay, Sentinel is the high resolution. So I suppose I work the Landscape, no problem. Landscape. Suppose I just click on the Landscape A. So here you can see different types of top of atmosphere or surface reflectance. Suppose I want to work for the top of atmosphere. This image collection I want to use. So first of all, this image collection I want to import in the Python environment. Okay, because when you apply the machine learning or deep learning for your classification, so then we have to import our satellite imagery. Okay, so now we just call the satellite image from Earth Engine public data catalog. Okay, we don't need to download any kinds of satellite imagery. We can easily access it from the Earth Engine public data catalog, and then this satellite imagery we can easily apply for making the land use land cover classification, or making the LST or NDVI or EVI or any other types of remote sensing analysis we can easily do it. So just I simply copy this snippet. All time we copy the snippet and then paste here. Then I just give a variable name. Give a variable name. Suppose I put the variable name is that Landscape. Okay, Landscape. So this is my satellite image collection, and this image collection I import in the Landscape. Okay, as well as I also need to import my study area. Okay, suppose I want to work for that this study area. Suppose Dhaka city, I simply import the Dhaka city boundary, or I want to work for your own study area, Fujimer. So for that, I just simply click on here. Here you can see we can get this type of things, feature collection. Okay, just I simply copy, and then paste in my code editor. Just paste in the code editor, and then just click to run. Okay, so now here you can see I just import my study area as well as also import my image collection. Okay, Landscape image collection, simply import. So now further, yeah,
Mr. Rahman, just 1 minute. 1 minute.
Okay, take your time.